Today's lesson is 614, Triangle Congruence Practice. And our essential question is, can I justify if two triangles are congruent? Yesterday, we discovered 4 different conditions for triangle congruence. Side, side, side congruence, which is where all 3 pairs of sides are congruent. Side angle side congruence, which is 2 pairs of sides are congruent and the angle between them is congruent. Angle side angle congruence, which is 2 angle pairs are congruent and the side between them is congruent. And angle angle side congruence, where 2 angles pairs are congruent and the side not between them is congruent. We have one more triangle congruence condition that we are going to take notes on today, and it is called hypotenuse leg congruence. So this is the 5th congruence condition or shortcut, and we abbreviate it HL and then the congruent symbol. So here is what hypotenuse leg congruence means. This is only for right triangles, because only right triangles have a hypotenuse and legs. In non-right triangles, we just call them the sides. But when we have right triangles, very specifically, the hypotenuse is across from the 90-degree angle, and the 2 legs are the sides that create that 90-degree angle. So hypotenuse leg congruence will only be able to be used in right triangles. And if your triangle doesn't, if it looks right, but it doesn't have that little square marking on it telling you that that's a right angle, you cannot assume that it's a right angle. Okay, so here's what hypotenuse leg means. So you've got 1 pair of legs being congruent and the hypotenuses are congruent, then the 2 triangles will be congruent. Here is a diagram of what that might look like. So first of all, I know that these are right triangles because of this marking right here. Anytime you have this little box marked in an angle, that means that it is a right angle. It is a 90-degree angle. All right, so I have my hypotenuse is labeled with the variable h, and so is this one. That means those 2 hypotenuses are congruent to each other because they have the same variable. And then here I have one of my legs is congruent to one of the legs here because they both have the variable L. So I can say that side length AB is congruent to side length DE because they have the same variable. That is a leg this time. Instead of just calling it a side, it's more specific, it's a leg. And I have AC is congruent to EF, and that is my hypotenuse. And I know that angle B and angle D are right angles. That is important. You can't use hypotenuse leg unless you have a right angle in your triangle. All right, that's enough information to say these 2 triangles are congruent. So now I can write my congruence statement. So triangle ABC is congruent to triangle. A is going to match with E, so I need to write E first. B matches with D, so D comes second. And then F matches with C. There we go. So here is my congruence statement for hypotenuse leg. The reason why hypotenuse leg works is because since they're right triangles, you could use the Pythagorean theorem to find the 3rd side. And since the 2 sides of one and the 2 sides of the other are equal to each other, that 3rd side has to be equal to each other as well because of the Pythagorean theorem. So that's the reason why hypotenuse leg works. Basically, we could extend it out to do side, side, side congruence, but just knowing those 2 sides and knowing that it's a right triangle is enough to kind of make it even more of a shortcut hypotenuse leg. So now I've got my 5 reasons or 5 conditions for triangle congruence, my 5 shortcuts for triangle congruence. There are some little nuances that you're going to see a lot in these problems where you're trying to figure out if the triangles are congruent. So I want to make sure that you have this in your notes as well, so that when you're looking at 2 triangles trying to decide if they're congruent or not, you can use these ideas to help you. The first one is the reflexive property. The reflexive property tells us that any shared angle is congruent to itself and any shared side is congruent to itself. You're going to see it most in this chapter with shared sides. So the reflexive property tells us that if you have a side like this one that's highlighted in yellow, that is a side length in both triangles, it's congruent to itself. I kind of made up my own little marking for this one. It looks kind of like a bow tie. That's how I always mark these sides that are congruent because of the reflexive property, because it's literally the same side in both triangles. So it has to be equal to itself. I know we talked about the reflexive property briefly first quarter, but here's kind of a more formal introduction for it for you. So you might see this kind of market or this kind of diagram where a side is being shared between the 2 triangles, and that is enough for you to say that that side length is congruent to itself because of the reflexive property. In similar triangles, sometimes we would see it with a nested triangle like this, where one triangle is completely within the other triangle and they share this angle right here. That you would be able to say that angle is congruent to itself because of the reflexive property. But for congruent triangles, most of the time we're going to use the reflexive property with a side length, where the side length is shared between the 2 triangles. Other things that I want you to remember that you're going to see a lot in this chapter with congruent triangles is vertical angles. Vertical angles are always congruent to each other. And when we talk about vertical angles, we're talking about 2 lines that intersect, and the vertical angles are across the intersection point from each other. So those 2 angles would be congruent, and also these 2 angles would be congruent. So when your triangles have an intersection like that, you might be using vertical angles to help you show that the 2 triangles are congruent. So vertical angles are always congruent to each other. So this is thinking back to chapter 2 stuff, those special angle relationships. Here's another one that's thinking back to chapter 2. If you see parallel lines, and remember, we'll know that the lines are parallel because they'll have that marking on the line, or it might have 2 little arrows on the line. If you see parallel lines, you should be thinking about some of those special angle relationships that happen when 2 lines are crossed by a transversal. The most common one we are going to see with parallel lines in this chapter is alternate interior angles. Alternate interior angles will be congruent when you have parallel lines crossed by a transversal. So alternate interior angles are congruent when the lines are parallel. So keep an eye on that one, because those might come up quite a bit as we're looking at these triangles and trying to decide if they are congruent.